All right. Today I'm going to share the last as the last speaker here to share our recent work on a topic called autonomous GIS. We call it the next generation AI powered GIS. So this is not a single kind of piece of work. The presentation today here, I want to pretty much summarize or just introduce the work that we have done, several works, including the definition paper of autonomous GIS that we published in the IJDE in 2023, and also several other works, two other works that we have it in the preprint. One is the GIS Copilot, and also the other one is Autonomous GIS Agent Framework for Geospatial Data Retrieval. And also just briefly mention about the GIScience, rewritten paper that we are working on right now is the GIScience in the era of AGI research agenda toward this, autonomous GIS. So, all right. And just a brief introduction to my team, my lab here. So this work is it's not possible without this my great student here who is working very hard and very smart. And this is an amazing team that I just want to acknowledge their work here. And the research area in my lab here is we focusing on several topics in GIScience: geospatial big data, spatial temporal computing, like HPC for geography problems, and also geospatial artificial intelligence. The applications, we aim to address a broad range of geography questions about hazard, public health, population mobility, environment, and climate change. So with the ultimate goal is to advance knowledge discovery and decision making here. So we have a lab website. I put the link here. Also, we have feel free to scan the code to visit the website to learn more about our work. So come back to the topic here. Generative AI or artificial intelligence in GIScience. So the previous two speakers gave a very good explanation about generative AI, introduction about Gen AI, and also its applications in different areas. So here for me, for our team here, we think AI can be used in GIScience from different category. You can think about this overall topic here. One is that we can use AI as information extractors. So as topic, Dr. Hu just explained or gave, is by extract the useful information, the location information from twists, or we can also extract the sidewalk, for example, from the street view imagery and all the other kind of utility information or facility information that is useful that we can get from an image or remote sensing data. And also we can extract water depth from the flood photos. So those are, we use AI, generative AI or just traditional deep learning or other AI method as information extractor. The second type is AI as spatial models. So we can use AI for air quality prediction, for example, and also for weather forecasting. There's some nice paper that we can use generative AI or AI for to forecast, predict the weather, and very well. And satellite image segregation, we can have the spatial AI models to do this work for us. That is better than traditional method. And the third category I want to share here is AI as a GIS agent, which is a topic that I'm going to talk about here today. So we think the GIS agent here is building blocks to achieve the autonomous GIS. And the agent can have different types. For example, we can have spatial analysis agent. We can have data discovery, data search, filtering, pre-processing agent, and also we can have this mapping agent, or even have agent to extract this information from different data sources. So this is the third category we want to just focus here as a GIS agent or geospatial agent here. So autonomous GIS, what's the definition or what is autonomous GIS? We define in our paper, we define the autonomous GIS as an AI powered GIS that leverage large language model or generative AI or AGI's general abilities in natural language understanding, reasoning, and coding to address spatial problems, with those automatic data collection, analysis, visualization, and even more in this GIS domain. So specifically, by using AI, we can use that the generative AI, for example, as decision-making core, like you can think as a brain, as a human brain, for example. And also we have the tool here, like the program, executive program, like Python as a hand, which is has brain, he can to do the things. The autonomous GIS here is able to perform spatial analysis autonomously by identify or searching the data automatically from existing data sources, or collecting new data if it is equipped with sensors or from existing sensors here. And also using the existing tools or developing new ones as needed to process data that it gathers to produce final result. So that's the overall definition or our vision of this autonomous GIS, and how to achieve this. So when we start to work on this work, we think about, okay, and think about spatial analysis here, which is a core component of GIS. We analyze spatial data. So we think the key to build to achieve this kind of autonomous school here, like automatic spatial analysis, is to build and run the processing workflow in an automatic way. So why? Because if you think about all the spatial analysis, I think it's safe to say that any spatial analysis, dealing with geospatial data, that you can consider that as a geoprocessing workflow. So we have a data input, spatial data. We have this, we process data, analyze that, we write that, with all kinds of GIS tools. Finally, we have this final result here, right? The final result can be a map, can be a report, or can be some other new data set that you generated from this process here. So the example I'm showing here is a typical site selection problem in GIS. I think probably you might be familiar with this kind of siting models. Like this one is using built with ArcGIS model builder to identify the suitable areas for a school, a new school here. So as you can see on the left side, we have several input for the spatial data set, and then we use different tools here at different operations. It generate all kinds of intermediate data output, and then use the input for another operation. Finally, we produce the final map. So typically for this kind of workflow here, we can build that, using ArcGIS model builder or other kind of model builders, like the QGIS also has a model builder like that, and to manually connect those together to build a workflow and to perform this analysis. And of course, we can also write a program, right, to achieve this process. Or you can even just using this tool manually in the ArcGIS or other GIS tool to perform this analysis. But either way, the point I want to make here, those processes it had to be done manually by a GIS expert or a spatial analyst to perform this analysis. So any spatial analysis you can think can be treated in this way with workflow. It can be complex or it can be very simple, just one operation, for example, like a clip, like a buffer, right? So since I don't have much time to get into details of this autonomous GIS, we do have a paper already published. So I invite you to read that paper if you find this interesting. So I just want to give you here an overview of the prototype system that we developed called GEO here to demonstrate, what autonomous GIS is and what we can do with that. So here you can see on this chart here, on this map, this diagram, you can see we have the spatial problems question here. Let's ask that in natural language. And then by leveraging the large language model or generative AI as a reasoning core, that we can create a solution graph here. We call it solution graph or geoprocessing workflow with different nodes here. And then we have those, each of these operation nodes here, and we can generate those Python programs, which you generate automatically again. And then we can assemble all these programs. You can think about Python function together to create a workable workflow. And finally, we connect all this workflow and then to run that in a Python environment in this case, and then we produce the result here. So this is the overall idea here. We come up with a solution and then we implement each step in the solution. Finally, we will run this workflow to create the final result here. And I want to show you some quick case studies that we also have that in the paper. The first one is a human mobility data retrieval and a trend visualization here. So this data, this map one, if you look at the task here, to show the monthly change rate of population mobility for each administrative regions in the France map. And I have some other requirement that you can just put it here. And also I want it to draw a line chart to show the monthly change rate. All right, trend of all regions here. And here I do need to give it a location, we'll tell it where data is. Here I'm also using a REST API, you can see. And with some specific kind of how to use the API. Just you think about this is provide more knowledge or guidance to the AI so it knows how to extract the data for now. So this is the result here based on the question and data. So based on the question itself here, the AI will generate the solution graph. This is a geoprocessing workflow. And it makes sense for if you look at each step here, we have data input, out some intermediate output, operation, finally the final output showing in this purple color here. And this one is the result map that shows this mobility changes using the data. And also we have a line chart here. You can see the trend for each month. And then finally, you can see these two results, B and C here, map and the rate is created using by running this Python program. This program here is corresponding to this workflow that's generated here. So that's the first one. The second one is a death rate analysis for the COVID-19 and the visualization at the US county level. Again, we have this question here, basically just like you want someone to do this for you. This is a task, you can just describe that your requirement and what kind of map you want and what you want to do with this data. The data is here. Okay, this is like you just have a GIS analyst that you do this work. You ask it to do the work for you. So this is the result here. Again, we have this workflow, geoprocessing workflow here. This is with input output for each node, and we have this final output on the right side. This 3 input data set on the left side as the green color, green node here, as you can see. And we have this code generated based on the solution graph, geoprocessing workflow, and also these 2 results here, map and also a scatter plot. So this is another result. Here I do have a quick video. I hope that to show you, just give you a sense of how this works in the backend, because we do have this system already open sourced. So this example, I believe, is the case 2 France human mobility data analysis. You can see this is the input task here. You can run this, anyone can run this in the Jupyter Notebook, but you do need the OpenAI API to run this, all right? You can try that, but you need the API to make this work. So we input this question data, and then you get this prompt for generating the workflow solution graph here. And I'm going to choose make it forward a little bit, and then you can see the workflow generated in this way. It's actually interactive. You can drag it to any place that you want. I think it's pretty nice in this to present in this way. Oh, I'm sorry. And I do want to show you that this is once the workflow is generated, and now it's generating and reviewing the code for each operation, which is each operation node, it will generate a Python function. You can see this operation, but the code is being generated. And also, I want to show you that now, once all operation nodes is generated, and it will put them together to generate a final program. Here we are reviewing the assembly code, which is the final program code. It will try to run the code. And if it's run successfully, it will give you the result, hopefully, but this time it get an error. And if an error occurs, so the system will send the error information to the AI and to debug it. And then it will try based on the error information, to revise the code, all right, to generate a new code based on this error here. So now it's debugging the code, generate a new code. And second try to run this generated program. You can see it's running the second try. You can set the number of try to 5 or 10. So here was 10 here, maximum number of tries. So the second time it successfully generates the result, as you can see that I showed you in the slides. All right, all this demo is online. Feel free to check it out. So we invite you to explore, test, and contribute to this project as it's fully open sourced on GitHub. You can download, and also, as I mentioned, you do need an OpenAI API to put there to run this program there. So I invite everyone to try and explore that. So in that paper, we in early May last year, we in 2023, we envisioned that the authoritative GIS, can also be used or serve as a co-pilot for the traditional GIS software. So we call it the GIS co-pilot. So we can use this natural language to communicate with a traditional desktop GIS, for example, ArcGIS or QGIS. So it can provide user a new experience of interacting with the software. And we also mentioned that it can be probably use ArcGIS, QGIS, and to display a chat box, as I just showed you, and then probably just ask question to do the spatial analysis in some way. So if you are interested in this, and I'm very happy to see that Esri, they have released a demo on February last year, to show their effort in trying to develop such kind of a co-pilot in ArcGIS. So feel free to check out their video. It's available online for anyone to view. So what I want to mention here to talk a little bit more about here is a GIS co-pilot that we developed for the QGIS, which is QGIS is open source GIS software platform. I believe most of you probably know that. So we have a paper published as a preprint here. So if you are interested in this, feel free to check out this paper. Again, it's available to anyone to read. What I want to show here is just some result that what you can do with this co-pilot. You can think this part of an effort to achieve this autonomous GIS, but again, it's just a co-pilot because we still need user, guidance along this process here. So this is a plugin that you can just QGIS plugin download. Anyone can download and install, and you can see this the interface on the right side. You have this code, code panel, information panel, and also you can put your questions, spatial task here, and also the data here. You can load any data, GIS data in the QGIS environment. It will directly be used in this query in your analysis. So I want to quickly show you some examples. So first one is Richland County terrain analysis, just using this co-pilot here. So this is a question we ask it to merge the 4 DMs into a single raster and perform terrain analysis for this county, Richland County here, including those kind of analysis here, functions. So this is a task prompt, and what we ask, and then you have this 4 DM data file, as you can see from here, loaded into the QGIS. And then it will generate those workflow for you and the code, and also those final result you can see from here. So we do have a 4 DM file that being merged, and also it's clipped based on the boundary of this Richland County here. So yeah, this is one example. The other one is showing this vector analysis, show the fast food accessibility analysis. So you can think the question here is analyze and visualize the fast food accessibility score for each county based on number of fast food restaurants. So what we are doing here, basically, it need to first perform a point in polygon analysis, like count how many points in each polygon, and then create a thematic map to show the spatial distribution. I mean, in this way, in the county level, and also link this data, do a spatial join with, or do a join operation with this each county, and also the fast food, and also other information that we provided here. And then it will create those scatter plot and also create a regression line here. So we also have this demo and data set available online, so anyone can try that yourself if you are able to have the to download and have the OpenAI API created. So just a quick, I want to just show you some quick reactions as community reaction that we have when we share those co-pilot here. So we do receive a very good kind of response from the GIS community, and also we have some users that has this software or this Copilot and give very nice comments here. You can see this guy from this researcher from UK, Sasaki from Japan, I believe, and he tested this plugin, and he just super excited about what the plugin can do for his work, for his analysis. And also recently we have another user, Jamie Whittle, and he created a video about testing how to use the Copilot, and also using some examples to demonstrate its limitation, also its ability. So I invite everyone, if you feel free to look at this link, and then you can see the video about this test here. So with this being said here, I invite everyone, please try to you can please download this latest version of the Copilot from this QGIS official website. And also we have this test cases data set all made available publicly, so you can download online. And also we have this GitHub page, so anyone can contribute to this project. And lastly, just quickly, as I mentioned there, we also developed a spatial data downloading agent. Again, this is also we have a publication. Again, if you want to learn more details, feel free to check it out. And it's a QGIS plugin. You can just ask questions to download data. Now we have OpenStreetMap open, and also some other data sources integrated. You can just say download the data, the county boundaries in the US or in other parts of the world. You can also download some DM data that we have the data source description in the paper. So feel free to try it out here. And we do have a link here. So feel free to just download this plugin. A quick demo showing here data. All this data you can see in here is basically downloaded using different prompt here. And we do have video demos and the GitHub data project. Feel free to check it out. So finally, as we mentioned, we have been working on a vision paper to look at this potential research agenda to achieve the autonomous GIS. So in that paper, we envision the levels of autonomous GIS. We define that into 6 levels, just inspired by the autonomous vehicles. So with level 1 and level 0 and level 1 being fully manual, and then gradually we achieve some levels autonomous in level 2 and level 3, and finally to level 4 and level 5, which is fully autonomous. So we have some description here. So I believe the work that we are doing, and also there are many other works that we reviewed in this paper that is currently in the level of level 2 or level 3, which is a workflow aware. It can generate the workflow, generate the code, and perform the analysis, but still with substantial human interaction. Like you need to prepare the data in some way, and also you need to interpret the result by the human. So that's what we are right now, that we believe. And so stay tuned for this paper, and we are going to publish that. Hopefully get it published in the later in summer or later this year. So as Ms. Liu just mentioned at the beginning, we are also have a special issue with the same topic here. We look forward to your contributions. If anyone are interested in contributing to this topic here by using AI, generative AI for GIScience work, so you are very welcome to submit your work to this special issue. And also feel free to share anyone that you think might be interested in this work, this work here. We do have the link here. And thank you. That's it. All right.